Welcome back. Today we want to look at binary digits, base 10 digits. We'll be looking at IP addresses and subnets. So let's get into it. We all know that computers only understand zeros and ones. A zero or a one is a binary digit. So computers only speak in binary digits, only zeros and ones. The term binary digit, when you shorten it, it becomes a bit. So the way we represent binary digits is by calling them bits. Let's switch gears and talk about decimal numbers. These numbers are also called base 10. They're also called base 10 numbers. We all know about ones, tens, hundreds. We remember that from high school or from primary school. Now, let's break it down for you to be able to understand what base 10 is. So, a number such as 352, this number is written as 352 and the base that is under it is base 10, like that. So if we think about the ones, tens, hundreds, ones simply means 10 raised to the power of 0. And if you do that, you get that's 1. So that's ones. And then 10 raised to the power of 1 is 10. That's the second part of the number, tens. And then hundreds is 10 raised to the power of 2, which gives us hundreds. So a number such as 352, this number would be 3 times 10 raised to the power of 2, which gives us 300 over here. 3 times 10 raised to the power of 2, which is 300. Then 5 times 10 raised to the power of 1, which will give us 50. And then 2 times 10 raised to the power of 0, which will give us 2. That's where we get 352. I'm going to show you with a number such as 100. So 100 would be 100 is a base 10 number. If we look at it, 0 is at ones, 0 is at tens, and then 1 is at hundreds. So that is 1 times 10 raised to the power of 2, which is 100. 0 times 10 raised to the power of 1, which is 0. And then 0 times 10 raised to the power of 0, which is another 0. That gives us, when you add them all up, it gives us 100. I know I just went crazy with breaking down numbers that we already know, but stay with me for a moment. We are literally building up to something. As we know, decimal numbers are base 10, binary digits are base 2. So to convert a decimal number to binary, we would repeatedly divide the number by 2 and record the remainder after each division until we get to 0. Then we would read the remainders from the bottom going up, and that would be the number in binary. What do I mean? Let's say we are converting a base 10 number such as 100, we are converting it to binary. We would divide 100 divided by 2, it would give us 50, and then we would write the remainder, it's 0. 50 divided by 2, it would give us 25, the remainder is 0. 25 divided by 2, it would give us 12.5. So 12 and the remainder is 1, okay? 12 divided by 2, it would give us 6, the remainder is 0. 6 divided by 2, it would give us 3, the remainder is 0. 3 divided by 2, it would give us 1.5, but that's simply 1 and the remainder is 1. 1 divided by 2, it would give us 0, the remainder is 1. And when we read this number down going up, we read the remainders down going up, it's 1100,100. So 1100,100. 100 at base 10 is equals to 1100,100 base 2 in binary. So 100 in binary is 1100,100. Another thing, we need to also learn to convert binary back into base 10. And converting binary into base 10, we just take our number 1100,100 because that's what the computer understands. So computer understands 100 as 1100,100. Now we want to convert it back to base 10 for human beings to be able to understand what number is this. The way we did, remember in base 10, we did ones is 10 raised to the power of 0, which is equals to 1. Tens is 10 raised to the power of 1, which is equals to 10. Hundreds is 10 raised to the power of 2, which is equals to 100. So we would do the same down here. The first 0 over here is like our 1. So this last 0 over here, it will be 0 times 2 raised to the power of 0. And then the next part, it's 0 times 2 raised to the power of 1. The next number is 1 times 2 raised to the power of 2. Then it's 0 times 2 raised to the power of 3. The next number is 0 times 2 raised to the power of 4. The next number is 1 times 2 raised to the power of 5. The next number is 1 times 2 raised to the power of 6. When we add all those numbers together, so 1 times 2 raised to the power of 6 is 64. 1 times 2 raised to the power of 5 is 32. This is 0, 0, that's 4, that's 0, and that's 0. When we add all this together, add all the values without the zeros, we get 100. And that's where we find converting this base 2 number, which is 1100,100, to our decimal number, it will be 100. So 1100100 is equals to 100. So what have we done so far? We've converted a number into binary, and now converting it back to base 10, we have to multiply all these numbers by the power of 2. So that in base 2 is equals to 100 in base 10. Now, moving forward, let's connect all that. Why did I go through all that rant of converting decimal numbers into binary and back into decimal numbers? It really comes in handy right here. When we think about IP addresses, an IP address or Internet Protocol address is a unique number given to every device on a network to help it send and receive data. So IP addresses are the ones that help us actually send and receive data. When my computer is trying to talk to your computer, it's talking to the IP address. The IP address is literally like the house number. So we did ipconfig and we got our IP address there, something like 192.168.56.1. Now, let's talk more about this IP address. The IP address itself, it's built up of two different portions. There is the network part and the host part. The network part represents what network your computer is on. You remember when we were trying to talk about connecting computers for them to be able to communicate, and we had them in a local area network, and we connected them to a switch, and they were able to communicate like that. So the network part shows the local area network. It shows the neighborhood. It shows this is where you are. And then the host part shows, let's say, the house number, the device number on the network. What do I mean? Here it is. So a network part, something like 192.168.56, this is the network part. So all the computers in that network would start with this 192.168.56. That is their network part. That is their neighborhood. They're in the same local area network. And then the last digit shows the host. So it shows this is computer number 1. So host 1. And then there is another computer, let's say host 2. So it will be 192.168.56.2. That's the second computer. Then .3, that's the third computer. Let's go deeper. As I've said, network part shows which neighborhood. So let's think of it as if we are in an estate. The first part, the network part, is high-rise estate. So 192.168.56. The more we dig deeper, we'll realize that the .0 is reserved for the network address. So this is the network address, 192.168.56.0. We don't assign any computers with 0. So 192.168.56.0, that's like saying high-rise estate. And then we have the gate. The gate is mostly our router, because we remember when we were going to the other network, we are using a router to be able to connect different networks. So we leave through the gate and go to the next network. So the gate is our router. And most of the time on a network, we usually give the gate the host 1. And then now, when we have houses inside that estate, we have the first house, 192.168.56. This is the network address, and then house number 5. So this is computer number 5. Let's go to this other estate. And Madaraka Estate, their network address is 10.10.10.0.0. So that's their network address. And then the gate, their router, the gate gets 10.10.0.1. And then the houses over there, we have 10.10.0.10. That is house number 10, or host number 10, computer number 10. 10.10.0.11, that's computer number 11. Okay, now we already know about the network part and the host part. How do we actually know what is the host part and what is the network part? In an IP address, to identify what is the host part and what is the network part, we need the help of a subnet mask. What is a subnet mask? A subnet mask is a 32-bit number that separates an IP address into two distinct parts, the network portion and the host portion. Understand what 32-bit is. Because we said bits are ones and zeros, so it's either a 1 or a 0. So 32-bit would mean 32 bits, literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So if we had something like this, all these are bits, yeah? And all these bits are zeros. So 32 bits, that's what a subnet mask is. 32-bit number. So it could be either zeros or ones or zeros and ones all together, but it needs to be 32 bits, okay? So a subnet mask is a 32-bit number that separates an IP address into two distinct parts, network portion and the host portion. 192.168.56, that's the IP address that we have. A subnet mask for this IP address, we are representing this subnet mask in base 10. I know I said 32-bit, which meant it's either ones and zeros, but I want to show this subnet mask first into base 10 because that's what human beings understand. We understand that faster than if I wrote this thing into binary, you know? But anyway, we're going to write it into binary next. So the subnet mask, if you've seen something like this, 255.255.255.0. So if I see a subnet mask that is 255.255.255 and then 0, I'd know that 255.255.255, this shows that the first part of the network part is full. So this is 255.255.255, that's the network part, and then .0, 0 is the host bit. So 0 is the host part. Now I can assign any number that I want there, and that will show my house numbers. What do I mean? Let's go deeper. So we want to convert this subnet mask into binary. We've already learned how to convert things into binary, right? So a subnet mask such as 255.255.255.0, let's convert it into binary. 255 represented as binary is 1111111. That's 8 bits of numbers. I forgot to mention this. Even though a subnet mask is a 32-bit number, it's broken down into octets. So octets would be something like 1, 2, 3, 4, 5, 6, 7, 8, and then we'll put a dot there. Then we'll go again to 1, 2, 3, 4, 5, 6, 7, 8, and then we'll put a dot there. This time I'm going to change it into ones. 1, 2, 3, 4, 5, 6, 7, 8. That's another dot. And then 1, 2, 3, 4, 5, 6, 7, 8. If you look at this number, this is still 32 bits. 32 bits divided into octets, yeah? That's how subnet masks are. We divide them into octets. Going back here, 255 broken down into binary is 111111111. That's the first octet of our subnet mask. We'll also convert the next octet, the 255, into binary. That's also 11111. Convert the next octet into binary. That's 11111. And then convert the 0 into binary. Those are just zeros. And the whole number, this is 32 bits, all right? That is 32 bits. And then this is how it looks when we convert this subnet mask, which was in base 10, into binary. It's 11111, 11111, all the way to 00000. So the way we know which part is the network part and which part is the host part, this is the rule of thumb. All the ones represent the network bits, the network portion of the subnet mask. And then all the zeros show us the host bits. So we see that we have 24 network bits and then we have 8 host bits. Another way to represent it, it would be like this. We would write a /24 because we have 24 network bits. So if I see a /24 network, I'd know that the subnet mask of this network is 255.255.255.0. The IP address can be represented like this with that subnet mask, which is 255.255.255.0, or it could just be written like this to make things easier. 192.168.56.0/24. With /24, it means there are 24 network bits. There are 24 ones, and then 8 host bits, 8 zeros. So if I see a /24 like that, I would know that it's 255.255.255.0, okay? Or it's 24 ones and then 8 zeros. Now, let's get to see how many computers can we assign to this network. To find how many computers we can put on that network, we look at the host bits. So we have 8 host bits in our /24 network, in our 255.255.255.0 subnet mask network. To find how many hosts we can have on this network, we'll just do 2. Remember, we are dealing with base 2 now, which is binary. So 2 raised to the power of 8, 2 raised to the power of host bits that we have. We have 8 host bits. So 2 raised to the power of 8 is 256. So we have 256 possible addresses, possible computers that we could put on this network. Only 256. That would mean our IP address 192.168.56.0/24 would contain IP addresses from 192.168.56.0 all the way to 192.168.56.255. So we have all this range from 0 all the way to 255. We have 256 possible addresses, but we won't use all of them to assign computers to them. We only have 254 possible computers to connect to this network. Let me break it down and see what do I mean with this. So with 256 possible addresses, we need to think about, first things first, we have the network address. This one is determined. This one stays. This one we can't control anything over it, because the network address, that's the first part of the IP address. It shows us what network are we in. It's like saying high-rise estate. So that one is already taken. And then house number 1 would be high-rise estate, house number 1. High-rise estate, house number 2. You see? So network address, that one is already guaranteed that it's already taken from the 256, leaving us with 255 addresses. So our network address first is 192.168.56.0. It takes the first address. .0 was the first address, okay? The .0 was the first IP address. So it takes that address. And then there's something else called a broadcast address. Because remember, on our network, sometimes one computer wants to send the same message to all the computers on the same network. I know that's what a hub used to do, because it used to send broadcasts. So it would send the same message to all the computers on the network. But now, even with a switch, sometimes, as much as we send messages directly, because switch helps us to send a message directly from one computer to the next computer without having to broadcast it to everyone. But sometimes you want to send a broadcast message. It's just the same as when you are on your WhatsApp. Sometimes with the people that are close to you and the ones that you want to talk to the most, sometimes you want to send them sometimes you send them direct messages, but also you might put them in a group and send a broadcast message. That's the same thing here now. We need a broadcast address, and that broadcast address is there by definite. That one is already decided, okay? So we can't, as network admins, it's not like we can play around with that. It's not like we can play around with the network address or the broadcast address. And the broadcast address is usually the last IP address in the IP address range, okay? So the broadcast address takes 192.168.56.255. So if we look at it now, from our 256, we only have 254 addresses to play with, okay? So that's how we have 254 computers that we can assign to this network. The only usable addresses that we can use is from 1 all the way to 254. So 192.168.56.1 all the way to 192.168.56.254. But here's another caveat. We still need to think about the default gateway, because even if we have computers on a network, we need to think about when they are now trying to talk to the other computer, another computer in a different network. The same way we were talking about estates up here. If I live in high-rise estate, sometimes I want to go to Madaraka estate and talk to 10.10.0.10. Yeah? So the only way I can go outside my estate is using the gateway, is using the router, okay? A router connects two different networks. Our router, most of the time in most networks, our router gets the first IP address, okay? It gets the first IP address. So our router is also called the gateway. Most of the time, we would give it 192.168.56.1 to show that this is our router IP address to direct all the computers on the network. If they want to leave the network, they go through our router IP. Meaning now we are left with 253 computers that we can eventually connect to this network. We can always change the IP address of our router. We can decide to give it something else. Instead of giving it one, I can give it like .254. That's towards the end. That's closer to the broadcast address. I could give it even somewhere in the middle. I could give it 100. I could give it. So this is now open to me to whatever I want to build on my local area network, whatever I decide to give my router as the IP address. So the key takeaway is in a /24 network, there are 256 addresses. The first address on the network is the network address. The last address is the broadcast address. We are remaining with 254 addresses that can be assigned to devices. And in these 254 addresses, we need to assign one to the router and then the rest to the computers that we're using, okay? Now, I have a question for you. If you've understood everything that we've done with subnets, go ahead and try to do this question. The question is, given the IP address 10.10.10.0/17, could you determine the subnet mask? And also, could you determine the number of usable hosts? So pause and try that. Okay, and we are back. Let's solve that question now. Given this /17, can I determine the subnet mask and can I determine the number of usable hosts? So to determine the subnet mask, /17 means 17 network bits. Remember that. When we write it in binary and we write it in octets, so as we're writing our subnet mask, we are writing it in octets, yeah? So we would have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16. And then I'd add a network bit right there. I'd add 1 to make it 17. So all this is our /17. And then we have the rest. We have 15 host bits. So that means we have more computers that we can connect to this network, okay? Let's convert each octet to decimals or base 10 numbers so that we can understand this stuff. We would have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. That gives us 255. So our first octet is 255. Then our next octet, of course, would be 255 because it's the same number. Now, to convert our third octet, 10000000 into base 10, this would be 1 times 2 raised to the power of 7, which gives us 128. 128 plus all the zeros is 128. So that means our third octet, this is 128. If we write this in a subnet mask that is in base 10, it would be 255.255.128.0. That is what a /17 is. 255.255.128.0. Now, let's get the number of usable hosts. We have 15 host bits. So to get the number of usable hosts, it's 2 raised to the power of the number of host bits, 15. That gives us 32,768. So we have 32,768 possible computers to connect to this network for them to be able to communicate. See that? Now, with 32,768, we need to think about our network address, our broadcast address. We need to take those ones out because those ones are definite, like they'll be used. So when you subtract 2, we are left with 32,766. So this is the number of usable hosts. But also, we'll still need to take away 1 for the router, and we could give it anywhere in that range. So we'll take 1 for the router, and the rest will be left for our computers. Anyway, if you did that and you got those answers correctly, you can clap for yourself. If you still have issues understanding everything that we just did, please go back and watch the videos and you'll be able to grasp. Ask any questions in the comments section below and I'll be happily ready to answer you or guide you in a place that you do not understand. I hope you found this video interactive and interesting and informative. I hope to see you in the next video.